Today I want to start right where we left off in 15 and 16. One of the challenges to these problems is punching it in the calculator correctly. So I want you to start today by trying 17 on your own. Let's see if you can get it set up, see if you can find the common ratio. It is pretty well set up in the A1R to the N-1, so that should be able to help you identify some things. But let's see if you can try 17 and get in the calculator correctly to start. Okay, so pause now and give it a shot. Okay, now if you're not recognizing the first term in the common ratio, yeah, it's fine. Just like the other day, you can expand this. If this is the formula, we should know how to expand it by putting in these input values. So we just got the first three terms going. 1, 3, 9 is the sequence, so we can easily identify the common ratio now. If you want to do that for this problem, you could. The shortcut is to grab the common ratio right here. It's 3/5, so throw it in the formula here. Okay. Formula also calls for A1, okay, and A1, so we got to grab that right here. It's 625 or plug in 1 if you want to verify that. Okay, so there it is, plugged into the formula. All right, now moving forward. Now, a lot of mistakes happen on going from here to the calculator. One piece of advice might be you might want to do this piece by piece. Just figure out what the numerator is. Write it down. Decimal form will be fine. Figure out what the denominator is. Write it down. And then divide those decimals and then multiply by 625. That might be the safe approach. I'll show you a way right now to punch in this whole fraction, and then we'll multiply by 625. So if I want to break up numerator and denominator, I got to close my numerator, close my denominator separately. So that's what I did here. 1 minus 3/5 to the 40th power, and I have to divide that by the denominator, and I need to close that. And now I can do 1 minus 3/5. Parentheses are not, I'll put in parentheses just to be safe, but don't really need it. So I close the numerator, close the denominator. I just hit enter, and there we go. There's this part, 2.49, almost 2.50 basically, if we were to summarize that, right, or round it off. You'd probably be safe just writing 2.50. All right, so now I just got to multiply by 625, and I'll be done. Okay, so I get 1562.5 approximately. All right, so that's why we do OTI. That's why we do practice problems, because it takes a little while to make sure you figure out how to punch it in the calculator correctly. Okay. Okay, so look at this next set of directions. It says use summation notation to write the sum. We did problems like this back in 9-1, and on your last quiz, you guys actually did a nice job on this problem. I think it was a lot kind of like this one, where I think it was 1/3n maybe. All right, so I gave you these 3 steps before. The only difference is now the a sub n formula, we can use the geometric a sub n formula. Okay, so like I said, we've done this back in 9-1. The difference now is we're going to use a specific formula. If you want to rewrite these steps in here, go ahead, jot this down. Step 1, get the a sub n formula. Okay. Sample 19. 2, once we get it, this is where it's going to be a little different too. We might need to kind of use some guess and check strategies. All right, I'll even give you the option to use logs to find the n values. Bringing in some chapter 3 skills if you want, but guess and check is probably going to be the preferred method. And then once we figure out the n value is, we just throw everything in the right spot. Express using sigma. Okay, so similar flow to the 9-1 steps. All right, what we want to notice here for 19 is this is geometric. Okay. So there's a multiplier, right? We're multiplying by 3 to get to the next term. Okay. You might want to put the n values underneath it. Usually we could just look at it and figure out the formula, but this one might be a little bit tougher to do. So since it's geometric, let's use a sub 1 times r raised to the n-1. First term is 3. The common ratio is 2 raised to the n-1. Okay, so that's the part that's going right next to sigma. That's the formula, right? That's going right here in this spot. Okay, now we got to figure out what to put on the upper and lower limits. Okay, and that can be tricky. What is the possible n value right here that creates 1536? Well, we can use that to our advantage. what n, when plugged in, gives me 1536. So this is step 2. Let's take this 1536 and throw it right here. So 1536 is 3 times 2 to the n minus 1. And this is where you can kind of guess and check. I don't know. I mean, obviously it cut off at 3. So maybe this is a 7 or an 8 or 9 or 10. There's a way to also do logs. This is probably not going to be preferred. I'm not going to actually write this down in the notes. I'll just show you real quick. But we could divide by 3 to both sides. So it's 1536 divided by 3. We get 512. Okay, remember in chapter 3, we had problems like this. To get this out of the exponent, we converted to a log. So I'd say log base 2 of 512 equals my exponent, like that. And then I can go to my calculator, plug that in, and add 1, and I get my answer for n. Okay, so if you're comfortable with logs, feel fresh on that. That's one way to do it. Another way is just to start randomly guessing and checking, or you could use your table. If I go to y equals and plug in 3 times 2 to the n minus 1 and go to my table, I can start scrolling up and down until I find the 1536. There it is. All right, so I give you 3 options. Guess and check, just start spinning your wheels in the clear screen. Use your table or solve this and use logs. Options are good. You pick. I don't care. Okay? All right, so n is 10. Okay, so n equals 10 to solve that equation, which means that's this value right here. Okay. All right, let's throw everything now in its spots. The third step, expressed using summation notation. So find the sum of 3 times 2 to the n minus 1 from an n value of 1 to 10. That's our answer. Okay. All right, you try it with 20 and choose whatever method you want for figuring out that ending n value. All right, first things first, what is that formula? What's the common ratio? Negative 0.25 is being multiplied. So remember the skill yesterday, take a number, divide it by its previous. Just make sure it's common, and it appears that it is. So there's my common ratio. Here's A1 to the n minus 1. Okay. All right, now probably the hardest part is just figuring out where they ended. What n value produced this value? And that's the challenge. So once again, old-fashioned guessing and checking. Maybe it's got to be higher than 3, right? So maybe you start a 7 or 8 or 9 randomly, plug it in there, and see which one equals this. Maybe even check this decimal form of what that number is. So if you want to check the decimal form of that, it's 0.0039. Let's see which one works out. Okay, I chose to throw this in the calculator, though, to figure this out, right? Because that's what we're doing. Which value, when plugged in, gives me this? Or logs. But I threw this in, 64, negative 1/4 to the x minus 1, or you can put negative 0.25 there, and then let's just go up and down the table and figure out what gives me that same value. It's right here. An x value or input value of 8 produced that decimal we were looking for. That's 1/256. Okay. All right, so now we're ready to throw it all in the summation notation. A sub n goes here, 1 to 8. All right, let's transition here to the next page. Sum of an infinite geometric series. Really the last learning target, then we got some applications that we'll maybe do one today and save the rest for tomorrow. Okay, so this is when we can find the sum of an infinite geometric series, when the common ratio is less than 1. It's the scenario when this is approaching 0. So for example, if a common ratio was less than 1 when I took the absolute value, it might be something like this: 10, 5, 2.5, 1.25. Okay, obviously I'm taking half of each value here. This is approaching 0. Eventually, if I keep doing this over and over again, the values are going to be so small and minute that they just say enough already. Let's just add it up and we can actually come up with a sum, even though this continues on and on and on towards zero. Okay, so that's what it means by an infinite geometric series. When it approaches zero, we can do it this way. And it's actually a really easy formula to use once you get used to it. A1, and then you just divide it by 1 minus r. That's it. Okay, and that's why they use this infinite sign right here. So the sum from your beginning value to infinity will be equal to this formula here. This is the part you really got to focus on. Okay. All right, so we really only have a couple things we need to gather. I need to figure out what A1 is. I need to figure out what R is. 422. Okay, so to find A1, like we always do, plug it into this formula. So A1 will be 1/3 raised to the 1 power, so we get 1/3 for A1. Okay. Common ratio is usually what's being raised to the power, but if you weren't sure, we could go check, see what A2 is real quick to make sure we know what the common ratio is. So if I did A2 to confirm this, it'd be 1/3 squared, which is going to be 1/9. Okay, looks like we can confirm this now, right? We're multiplying by 1/3 to go from here to here. Okay. All right, so let's go ahead and find the sum. The sum will be equal to, using this formula, so S equals A1 over 1 minus R. So that will be, we kind of box this off a little bit, 1/3 on top divided by 1 minus R. Now, if you go to the fractions, we probably don't even need the calculator because 1 minus 1/3 is 2/3. And then can you multiply by the reciprocal to get your answer and not pick up a calculator? All right, but sometimes they're messier and decimal-like. So here's my advice when we're punching this in the calculator. Close your denominator. You have to separate these to get this right. Okay, so 1/3, I'll even separate the top two just to be safe. There's my numerator divided by my denominator. Close it with parentheses. Okay. All right, so it gives me 0.5. Okay, so our answer for this, oops, I'm going to punch that in wrong somehow. All right, just realized I found my mistake. Thanks to Owen. Yes, the first term is 0. I went too quick and plugged in 1. So the first term of the sequence here for the sum from A0, and we plug in 0 here, anything to 0 power is 1. So that needs to be what we put in right here, okay? All right, but the common ratio will be the same because then when I go on to the next term, it's 1/3, and the common ratio you can see is 1/3. All right, so 1 divided by, close the denominator, 1 minus 1/3. Okay, and we end up with 1.5 or 3/2 for the answer. Okay. All right, pause and try that for 23, and then we'll apply it to 24 and 25. All right, this happened yesterday on 16, so just a heads up. It can be a little confusing sometimes. Really, in these formulas, when they say A1, it's the beginning value. Happened here on 16 as well. To find the sum, A1 was the first value. It was 4 in this case because 0 is where they wanted you to start. All right, so get the beginning value. It is 8. Common ratio is 0.4. Expand it if you need to, but it's going to be that number right there. And we get 8 divided by 0.6, 13 and 1/3. Okay. Now, it might not be in summation notation. It might look like 25. Okay, so let's kind of do 25 together. We'll skip over 24 for now. Once again, this value, the sequence looks like it's approaching small numbers. These are getting smaller and smaller, approaching 0, so this is possible. So the common ratio would be any of these numbers divided by the previous. Just choose one. 18 divided by 24, and then we'll just reduce the fraction. So 18 divided by 24, and that's 3/4 or 0.75, whichever one you want to use. Okay, so with that in mind, go ahead and try to finish up and find the sum on your own. All right, there we go. There's your sum, 96. I was going to do some applications today, but we're running out of time, so we'll save the applications for tomorrow. Probably a little introduction to 9.5 as well. That's it for today.